Alright guys, next parallel circuit. What do we got? 100 ohms, 330 ohms, and 470. And our source voltage is 120 volts. So it's a parallel circuit, so we know that our voltage will go right across. So first step is to drop in the voltage right across. Second step, you can find your total resistance using the reciprocal equation, right? So you could use RT is equal to 1 over 100 plus 1 over 330 plus 1 over 470. So we could use that equation there. And doing that with that equation and keeping all of the decimal places, I'm getting 65.971 ohms. So you could do that, or you may want to go along and find your individual currents, right? We know that for this circuit, our total current is going to be equal to I1 plus I2 plus I3. So maybe this guy gives you a rash. You want to stay as far away from it as possible, so maybe you want to find your individual currents and then just add them up. So let's do 120 divided by 470. That gives me 0.255 amps. Now, I'm telling you right now, this is not going to work out to be 65.971 when we get back here, because when I do 120 divided by 470, I'm getting 0.255319149. So disgusting amount of decimal places there. I've decided to keep 3 of them. Let's do 120 divided by 330. That gives me 0.363. Okay, and then obviously the 120 divided by the 100 gives me 1.2 amps. Okay, let's add those guys up. 1.2 plus 0.363 plus 0.255 gives me a total current of 1.818. Okay, we were looking for a value that was close to 65.971. So if we had used, let's see, if we did the 120 divided by 65.971, we would have got a current of 1.818. Just so that it may have been rounded up a little bit because it's actually 1.8189. So essentially gives us the same current. Let's take the 120 divided by the 1.818 that we had, and that gives me 66 ohms as a total. Okay, so you can see that there's a little bit of difference between these two values. The difference is the rounding effect on each of our different calculations there. But everything else seems alright. We've added up all our currents. They sum to give us our total current. We've used that to find our total resistance. Okay, let's find our power values now. So we'll start over at resistor 3. 120 times 0.255 gives me 30.6 watts. Then I got 120 for resistor 2 times 0.363. That gives me 43.56 watts. Okay, and then I've got the 120 times the 1.2 amps, and that gives me 144 watts. And let's add everything up. 144 plus 43.56 plus 30.6 gives me a total, so let's write in PT if we just added those guys up, is going to be 218.16 watts. Okay, let's do voltage times current here and see whether we get a similar value. So 120 volts total times a total current of 1.818 gives me a total, oh look at that, it's very nice, gives me a total wattage of 218.16 watts. So these guys ended up being the same. So this is to reinforce the fact that it doesn't matter if it's series or parallel, the power equations will always be the same. It's the addition of all the power values summing to give us our total power. It doesn't matter if it's in series or in parallel. The heat required for this guy plus the heat required for this guy plus the heat required for this guy will be the total heat or total wattage required from the circuit. Alright guys, hopefully that worked out for you. You can stop it there and then you can hit play on number 8.